Hey Math 126 fans, here's the first part of my Math 126 topics review. I'm just going to briefly talk about vector facts. So if you go on my website, you'll see this, but these are things you should know. The length of a vector, you'll probably have to compute that somewhere, in particular when you're computing a unit vector. Scalar multiplication, which makes a vector longer or shorter. Vector addition, you should understand the basic idea. Dot products is more about knowing what it means. When you think about dot products, you should think A dot B. I'm just going to say a few quick things, then we'll look at some old exams and a couple of visuals, and we'll call it a day, and then you need to go practice more. This is the main fact, and that fact says if you take the two vectors and move them in a way so that they are tail to tail, and if this is the angle between them, then there's a connection between their lengths. It actually comes from the law of cosines, but proof of that is for another day. The cross product, the most important thing about it is it gives a vector that's perpendicular to the previous two, and you'd be really good at being able to check that. And then finally, projections and a few other things that come along with that. So the dot product tells you indirectly about this angle. The cross product gives you a vector that's perpendicular to two given vectors. And the length of the cross product happens to be the same as the area of this parallelogram. So if the area of this is 10 square inches, then the length of this is 10 inches. That's really it. There's a little bit to say about projection, but I'm sure we'll encounter that in a problem. Okay, so let's look at an example. So this is just one of my old exams. You need to have a plan. There's a lot of small skills here, so you need to have looked at lots of these. You can do that quickly by flipping through old exams. Find the area of this parallelogram. So you have to think, oh, this is asking about this cross product idea. Now, the number one skill that's always in the background is finding vectors. Like if you want the vector AB, you should think of vectors as changes. How much does X change? How much does Y change? How much does Z change if you go from A to B? So it's three little subtractions. Okay, it's always going to be head minus tail. So it's going to be 1, 2 minus 1, 3, this is 2, and 7, so this is 5. And then I would also do A, D. Now I think because we're doing the area of a parallelogram, it doesn't actually matter, but I always choose them emanating or coming out of the same spot. In most applications, that's what we want anyways. 5 minus 1 is 4, 3 minus 1 is 2, 11 minus 2 is 9. Now it's just a cross product question. So let's come over here and do a quick exercise in that. 1, 2, 5, and we should never get cross products wrong. Ever. You're probably going to do them many times. I've only seen a few situations where I see something where I understand how they could have made an error. Why do I say we should never make an error? I mean, the errors I make tend to be miscopying, but I think I copied down correctly, and I think I subtracted correctly. Once I get there, this is what I do. I write this out, and my goal is to hold the fewest number of things in my head at once, because that tends to prevent error, and then I'll check my work, and there's an easy way to check. So by doing this, that's the one thing I memorize, I guess. I now just have little multiplications to do. I do 2 times 9, which is 18. And I could talk through this, but this is for something you've already been doing. And 5 times 2. So notice I've got it down to where I only have to do one multiplication at a time. This really prevents errors. Now I'm going to cover up the middle one. Do 1 times 9 is 9. Do 4 times 5 is 20. And I really like that I just have to do one bit of arithmetic at a time. This is 2. This is 8. Then I rewrite it as a vector. 8, negative 11. So 11 and negative 6. Now there's plenty of opportunities there that I could have made an error. So now is when I check. The whole point of this is this should be perpendicular to the previous two vectors. And so you should always check that. So let's check. 8 plus 22 minus 30 is 0. So I'm multiplying. Remember, if the dot product is 0, they're perpendicular. That's a huge thing. So then the next one, 8 times 4 is 32. 11 times 2 is 22. 6 times 9 is 54. It's so satisfying, actually. I like checking. Okay, last piece of the puzzle. What's the area? It's the length of that vector. So it's the magnitude of this vector. So I think maybe just for time, I'll write the square root of 8 squared plus 11 squared plus 6 squared. Done. That's it. So that should be something we're ready to do. Find a vector of length 5 that points in the same direction as BD. Well, we can find BD by doing some subtraction. 2, this minus this, 1 minus 3, negative 2, 6 minus 7, negative 1. If you want to do a double check, you could add that to this. So add 2, add negative 2, add negative 1, and see if you get these numbers. Yes, yes, yes. So there's a double check you could build into your routine. If you want to make a vector length 5, it's a simple strategy. First you make it length 1, then you multiply times 5. If you multiply times 5 right away, it's just going to make it 5 times longer. So we're going to make this length 1 and multiply times 5. In fact, you can do that in one swoop. Multiply times 5, make it length 1. So we're going to divide by the length. It's going to be 4 plus 1, which is 3. And so this is just going to be 5/3. So that's a conceptual idea that it pops up throughout the term. Okay, so then I have this visual, and this is from my lecture notes. I don't know that this matches this picture exactly, but it's the same idea. So the question says, find this point E. This is usually one of the more challenging questions for students. This point is perpendicular. It's right there, and we would like to find it. So what can we do? Well, there's a few things. So this is an example of a projection. A projection is a vector that if you go straight down, you'd be there. I think I have some other visuals from my lecture notes. There's a projection. And I've even made this one so I can move it around. So if you take Math 126 from me, this is the sort of stuff you get. So if I move this, there's a projection. Projection, project the other way. So it gives a useful measurement of how two vectors are in relation to each other. That's a projection. The length of that is a simple computation. So the length of that is A dot B over the magnitude of B. And that's really the only formula I remember when I think about projections. And that's sitting up here. A dot B over the magnitude. B is going to be whatever the ground is. The thing on the bottom, I find it easier to remember. The bottom is the ground. So let's say we're thinking of B as the ground. And we have this vector A, and we put them tail to tail. And we want this length. This length right here is A dot B divided by the length of the thing you're projecting onto, which is this. That's what that is. The rest of the problem, like if I need the vector, I just rescale B in the same way we did the previous problem. That's the only formula I remember. This comes from a little fact about the angle, but that's a different story. That's something I prove in class. And so here's the idea. If you want, sorry, this looks funny. If you want this point, let's go back here. I'm going to try to find the vector AE. I'll tell you why that would be useful in a second. But here's what I'm going to do. I'm going to do the projection. Let's do it in steps to kind of explain. I'm going to find the vector AB. I'm going to project it onto the vector AD. And this is an incredibly valuable thing. We don't use it a lot in this course, but it is really valuable. So yeah, it might be confusing initially, but whenever you're doing forces, you often are projecting one direction or the other. So I would like to project A onto B. And so you just do the dot product divided by the length of the thing you're projecting onto. So we're going to do A dot B over the magnitude of B. So the dot product is 4 plus 45 divided by the length of the thing we're projecting onto, which is 16 plus 4 plus 81. That's the length, but unfortunately that does not give me the point. So the hardest part of this question is the next step. So let's see if that comes out nice. And apologies if I'm talking ideas. If I've made a mistake, you can let me know, certainly in the comments. But right now the focus is on ideas. So this is the square root of 101. Okay, so I would like to find the vector AE. That's called the projection vector, but I just think of it as rescaling. I'm going to take the vector AD, which is 4, 2, 9. And I would like to rescale it so that it has this length. How do we do that? We are going to multiply, just like we did in the previous one with the 5. We're going to multiply by this, and then divide by the length, which is this. And then we get this vector A, E. Oh, the question didn't ask me this. I'm already done. I was answering a harder question. Well, let's keep going answering my harder question. 4, 2, 9. So if the question was just the length, I already did it. If the question was to find the point E, what you would do is you would take the point A, which is 1, 1, 2, and you would say, I need to change this much. So the point E would be 1 plus whatever 53 over 101 times 4 is. That's how far you have to change to get there. And then you would have 1 plus 53 over 101 times 2. And then you'd have 2 plus 53 over 101 times 9. So there's a clever little play on that. Other ones. Here's a question that asks for the angle. If you want the angle between two vectors, they do need to be tail to tail. So the important thing here is B has to be in the middle. So if you're doing this question, you did this in the homework, you need to find BA in that order, and you need to find BC in that order, and then you're going to find the angle between them. So 3 subtractions, and then you're almost done. So B minus A, so that's going to be -1, -2, -3, and then C minus B, so that's going to be 0, 3, -4. Then you have this theorem, A dot B is the magnitude of A times the magnitude of B cosine of theta. And we're interested in that theta. So you do a dot product, 0 minus 6 plus 8. You do some magnitude, you do inverse cosine. That's what's going on. But visually, you need to be thinking about this. You know, you're given these vectors, and you're given 3 points. Your first job is to construct vectors. So if I want the angle at P, I need those 2 vectors. Okay. Let's get back here. Hopefully you have the idea. Find the plane, that's for another part of this video. Find the coordinates of C. So now you start starting to get strategies here. If I wanted this C that's halfway between them, I would really like to find this vector, because then I could just add that to Q. So if you can find this vector, which tells you the change in X, change in Y, change in Z, whatever those changes are, you can add them to the coordinates of Q and you'll have C. And QC is exactly half of QA. So I think that's the strategy. Okay, I think I'm going to stop there. I think hopefully you get kind of the idea. Hope you're finding this helpful.